Okay, so inversive distance was defined to be between two non-intersecting circles. And what you get, so what the definition gives you is you invert them into concentric circles, okay? And then you have this radius B and A, with A being smaller than B. And the inversive distance, I call it delta, is equal to the log of B on A, okay? Or E to the delta is equal to B on A. Okay. So something kind of funny is going on here. So one thing, I guess, we could define this Coshine function is equal to e to the x plus e to the minus x on 2. Okay, so you can see it's an even function. It has kind of funny properties that look like, okay, so you have shine x. So this is an odd function. And they kind of have funny properties that make them look like sine and cosine. Okay. So if you think of a property, for example, like cosine differentiates into minus sine, right? And you applied it to this, you'd get something similar but not quite. So in this case, the derivative would actually just go directly there. Or if that's too advanced for you at the moment, then sine squared plus cosine squared equals 1. This, I think, will give you that sine squared, cosine squared minus sine squared equals 1. Okay. So it's kind of like some funny, like Shelbyville version of the sine and cosine functions. Okay. Okay. The thing that wants to be investigated is okay, so we have one situation where they have a cosine, okay? So let's have A, B, and C represent. So you have two intersecting circles, okay? Say you have like A and B are the radii. Okay. You have A and B are the radii. And C is the distance between the centers. Then this angle, so this is the angle of intersection of the circles, okay? So the angle of intersection satisfies this cos theta is equal to a squared plus b squared minus c squared on 2ab. Okay. Yeah. It's equal to that. See, I would never type this up because it just takes too long. Maybe someone else would want to type it up. But anyway, so the cos theta equals a squared plus b squared minus c squared and 2ab. Okay, and I guess what we want to show is cosh of something is somehow equal to something like this. Okay, for non-intersecting circles. It's kind of weird. Okay, so try to remember this. We'll see where we go. So let's pretend we have two concentric circles. Okay, c equals 0. Um, people even here. Okay. There's no one wants to talk, but it's alright. I probably should have just started with this. So this is like a and a prime. This is like b and b prime. What is this? A b prime b a prime. What is that? It's the cross ratio. So remember, it's the interval. It's b divides. So it's ac. So it's ab on b prime b, and then you divide it by the ratio which a prime divides ab prime. So it's a prime b prime a prime. So okay, so in this case, it's equal to, so b prime a prime is just the same on both sides, right? So just ab squared. So if you have the radius, the bigger one is radius b, smaller one is radius a. Okay. Bigger one is radius b, smaller one is radius a. Then this is just b minus a squared on, yeah, the primes are not really helpful because they're not inversions at the moment, but yeah. B prime B is the same as a, whoa, something went wrong here. B prime B is not, this is not what I'm after. I want, what's B plus A? It's AB prime. I want AB prime. Okay, I want AB prime. So maybe I just want this. Then I get AB prime on BB prime. That's not what I want either, is it? I want BB prime. Then I get or AB prime, or AB prime on B prime, A prime, or something like this. Maybe it's like this. I want A prime here. AB prime on A prime, B prime. And then this is P. Then AB. And then B. Yep, so BA. And then on A prime B. Yeah, that's what we want. Because then that gives you B plus A squared, B minus A squared. Okay, so since they're concentric circles, the B and the A give you, so B on A equals the inversive distance thing. So this gives you, so divide everything by A squared, right? And E delta plus 1 on E delta minus 1 squared. And you have E to the 2 delta, E to the delta plus 1, E to the 2 delta minus 2, E to the delta plus 1. Okay. So if we divide by E to the delta on top and bottom, we get E to the delta plus E to the minus delta plus 2 on E to the delta plus E to the minus delta minus 2. Okay, so you can kind of see where we're going with this. E to the delta plus E to the minus delta on 2. So then we divide everything by 2, right? So what we have is that this is equal to cosh delta delta plus 1 and cosh delta minus 1. Yeah? Okay. Yeah. Okay, so now let's imagine we have these two non-intersecting circles before we inverted them to concentric circles. Okay. Okay. So this is A prime. Okay, imagine before we inverted them. So then C is not equal to 0. Okay. And we have, it's still A prime, B prime. Yeah. Wait, let me just undo. Yeah, so it's A, B prime, A. Okay, so before we invert them, they might look like this. That's C. Okay. That's A. Yeah, so before we had the A, B's, and C's, kind of we only use them to get the inversive distance. So that this is the proper ABC now. So C is actually the distance between the centers, and B is the radius. Okay, so now the whole point of this is that the cross ratio is actually the same before and after inversion, so it actually still equals this. So it actually still equals this. Okay. Okay, but it'll have a different expression in A, B, and C now. So let's figure it out. Where is everyone? So AB prime. Okay. So AB prime is B plus A plus C minus plus C. This is like A B prime is A plus B plus C. No, wait, it's a yeah, it's A plus B plus C. Yeah. Okay. A prime B is so it's not quite B. It's B. It's B minus something, yeah. It's B minus A. But it's plus. This is B. Ooh. It's A prime B. So it's B. If you minus C and plus A, I think that'll do it. So it's B plus A minus C, yeah? Okay, then A prime B prime. A prime B prime is it's like it's B minus A minus C. So B minus A minus C. And then BA, it's B plus C minus A. So that's A plus B all squared minus C squared on B minus A all squared minus C squared. something plus 1 and something minus 1. Okay. So we're doing a squared plus b squared minus c squared plus 2ab on a squared plus b squared minus c squared minus 2ab. And then you have that a squared plus b squared minus c squared on 2ab. So you divide everything by 2ab plus 1. A squared plus b squared minus c squared on 2ab minus 1. So if we call this like w or something, yeah, then we have this equals w plus 1 and w minus 1. Does that actually mean that w equals cosh? Let's have a look. Well, obviously it's a solution, and if we just do some cross multiplication, we see the equation is linear, so it has to be the only solution. Okay, but let's just write it out, because I don't know, because we like pain. Okay, so omega cosh delta minus plus w minus 1 minus cosh is equal to w cosh delta minus 1 minus w plus cosh delta. So this cancels that, minus 1 cancels, and you get 2w equals 2 cosh delta, yeah? So, okay, so that, what does that mean? Okay, let's write this in the middle. So, w is this expression, so cosh delta equals, so a squared plus b squared minus c squared on 2ab. So the same expression for the cosine of the intersecting angle between intersecting circles, where AB are the radii and C is the distance between the centers, is given by cosine, okay, where the intersecting angle is replaced, because obviously they don't intersect anymore now. So for non-intersecting circles, it's replaced by the inversive distance. So the inversive distance kind of acts like the intersecting angle. It's kind of interesting. Yeah. Yeah, if you remember, this was equal to cosine of theta if the circles intersected.